Example 13.4b is going to continue looking at completely factoring a polynomial equation. Here we have g of x equals x squared minus 50x minus 275. This is an example of a trinomial. Trinomial just means that it is a polynomial that has three terms. Now, when you have a trinomial, you will often find that trinomial factoring is applicable. Trinomial factoring is applicable every time the middle term power, which in this case is a 1, is half of the power that's on the first term, and your last term is a constant. That's exactly what we have going on here. So this trinomial is ripe for attempting trinomial factoring. Doesn't mean that it's always going to actually work, but it does mean that we are allowed to try that and give that a shot. So for the trinomial factoring, the goal here is to take the trinomial and turn it into the multiplication of two binomials. So I'll always start with that first term, and here our first term is x squared. So to multiply to get x squared, and to distribute the multiplication evenly, I would say x times x is the best way to make that happen. Then after that, I want to do the same thing with the negative 275. But the problem with negative 275 is that there are multiple ways to multiply to get that. Whereas with x squared, x times x is really the only reasonable option for that. So we have to have another test to go along with this. Let's start with one pair that works with negative 275. That would be negative 25 times 11. That will give us negative 275. But if I take negative 25 and I add 11, I will end up getting negative 14. So this is a way to check whether or not you will be able to recreate that middle term of negative 50x. Clearly we're going to get negative 14 when we add those two numbers together, and that does not end up equaling negative 50. So that tells me that this pairing of negative 25 and 11 is not going to work for this particular trinomial. So let's just try another pair. Let's take 5 and multiply with negative 55. That will also give me negative 275. But this time, if I add those two numbers together, I'm going to end up getting negative 50, which does match what I'm looking for. So then I'm going to take the two numbers, 5 and negative 55, and I will create my two factors with those. So interesting here, the degree of g, if you're looking at the leading term from the standard form, leading term again is x squared. This would imply that the degree of g is equal to 2. And then when you look at your factored form, you have a degree 1 factor, and you have another degree 1 factor, and the 1 plus 1 adds up to give you 2. So not only do we get a nice representation for the factoring, this is also known as a linear factorization. So anytime you can have all of your factors being linear, that's when we call it a linear factorization.